Assalamualaikum and hi guys. So this video we explain about the modulus and argument for the complex number. So modulus is also known as norm or absolute. So whereby we have z is equal to a plus bj, the modulus, which is the notation, is r equal to modulus of z is equal to the square root for the whole thing, a square plus b square. So modulus is the distance point AB from the origin. So let's say this is our complex number, z is equal to a plus bj. So origin is 0, 0 here. So this is our complex number. So a for the real number, which is for the x-axis, bj, which is b for the y-axis. So the modulus is the distance from the origin to the complex number. Theta, this theta here stand for the argument. Theta is tangent inverse b over a. So where you have to find b and a here, b and a is from our complex number. So theta is equal to tangent inverse b over a, or the other notation for the theta is argument of z, whereby z is equal to a plus bj. Theta is between positive real axis and the complex number. So positive real axis is from the axis x here, positive real x-axis to the complex number. So this is our theta. So this is the step how to find the theta. So I will explain again the step when we want to solve for the theta. So we will have 4 quadrants, quadrant 1, quadrant 2, quadrant 3 and quadrant 4. So for the quadrant 1, so the theta is from 0 degree until 90 degree. So this is theta is equal to alpha. Alpha is the value for the reference angle, which is we get from the calculator. So for the quadrant 2, the theta is from the 90 degree until 180 degree. So this is our 90 degree. So this is our 180 degree. So this is our reference angle. So the real theta is from the positive real axis to the complex number. So this is our real theta. So for the quadrant 3, the theta is from 180 until 270 degree. For the quadrant 4, the theta is from 270 until 360. If you notice here, I write here theta is equal to alpha, whereby alpha is for the reference angle that we get from the calculator. For the quadrant 2 is theta is equal to 180 minus alpha, whereby 180, this is 180. So this is our alpha. Answer from the calculator. The real theta is from the positive x-axis until complex number. So that's why we minus 180 minus with alpha. For the third quadrant here, 180 plus alpha, because positive x-axis until reference angle is 180 plus with the reference angle. For the quadrant 4 here, 360 minus with reference angle. So this is our real theta. So let's refer to this example. Find the modulus and argument for each of the following complex number. So I will not explain the whole thing because we have 8 example here. For example 7 and example 8 here, you can refer to the video. So the rest I will discuss, and some of the example you have to try by your own. So let's try to do example 1. Z is equal to 1 plus 2j. So the question asks you to find the modulus and the argument. So the modulus is r is equal to square root of a square plus b square. So you have to determine what is your a and what is your b. A is equal to your real number, which is a equal to 1. B for the imaginary number, b, whereby b is equal to 2. So therefore, r is equal to square root of 1 square plus 2 square. So 1 square plus 2 square is equal to 5. So square root of 5. So if you cannot simplify the square root here, you just leave your answer like that. Okay, so this is the answer for the modulus. So now let us proceed to find the theta. Theta is equal to tangent inverse B divided with A. So our B is equal to 2, our A is equal to 1. So by referring to the step here, step 1 identify value for A and B. So this one there is no problem. Step 2 plot the graph. So in order to plot the graph, you have to refer to your complex number. So make an axis here. So you should have X and you should have your Y. So from your complex number, you have Z is equal to 1 plus 2J. 1 for the X, which is positive 1. So this is your 1. 2J, whereby your Y is equal to 2. So this is your 2. So from here, origin until your complex number. So Z is equal to 1 plus 2J. So this is step number 2. For the step number 3, find the value for the reference angle alpha from the calculator. So in order to find the value for the alpha here, use the formula theta equal to tangent inverse B over A. So tangent inverse B is equal to 2 over 1. So the calculator will give you the answer 63.43 degree. So this one no need to change into radian. So step number 1, determine A and B. Step number 2, plot based on your complex number. Step number 3, find your reference angle by using formula tangent inverse B over A. Step number 4, find the value for the actual angle or the real angle, whereby you have to ignore the negative sign. So for here, we don't have negative sign, but some of the example, maybe there is a negative sign at the front here. Okay, for the negative sign here, we will refer for the next example. So therefore, real theta from positive x-axis until complex number. So this is our positive x-axis. So this is our complex number. So real theta is from the positive x-axis until it touch the complex number. So therefore, the theta is from positive to the complex number. So this is our real theta. So means that the theta that we find before this is the real theta for the complex number. So therefore, theta is equal to 63.43 degree. For the next example, example 2, we have Z equal to negative 1 plus 2J. So find R and find the theta. So R is equal to square root of negative 1 square plus 2 square. So therefore, simplify, our R modulus is equal to square root of 5. So now proceed to find the theta for this complex number. So the first thing, you have to determine A and B, whereby you have known that A is equal to negative 1, B is equal to 2. And then you have to plot your complex number. So this is your X, this is your Y. Complex number is negative 1 plus 2J. Negative 1 for the X, whereby this one for the left hand side. Negative 1. 2J at the Y axis. So this is our 2. So this is the complex number, negative 1 plus 2J. So find the reference angle. Theta is equal to tangent inverse B over A is equal to tangent inverse 2 over negative 1. So tangent inverse 2 over negative 1 is equal to negative 63.43 degree. So this is what I mean, you have a negative sign at the front here. So if we have a negative sign, we ignore the negative sign. So we want to know whether this is our real theta or a reference angle. So before this, the theta that we find here is already the real theta because it moved from the positive x-axis until the complex number. But for the second example, based on our complex number here, is it logic that negative 63.43, if we ignore the negative here, the angle 63.43 is from the positive x-axis until complex number. So this one is 63.43. Is it possible or not? It's not possible, right? Because x and y here, this one is 90 degrees. So how come this one will become 63? So that's why this is not the real theta. This is the reference angle or the alpha. Okay, this is not real theta. But this is a reference angle which is alpha. Okay, so this is the alpha value. Alpha is equal to 63.43 degree. We ignore the negative sign here. So now you have to find the real theta. So therefore, real theta is equal to positive x-axis until it touch the complex number. So how to get the real theta from the positive x-axis until the real number? So therefore, the real theta is equal to 180 degree minus 63.43 degree. So minus here is not depends for this negative sign. We minus because we want to know the real theta from the positive x-axis until the complex number. So 180 minus 63.43 will become 116.57 degree. So this is the real theta for this complex number. So let us continue for the example 4. Z is equal to negative 6 minus 4j. So find the modulus for this complex number. R is equal to square root of a square negative 6 square plus b square negative 4 square. So square root for the whole thing, the answer is equal to square root of 52. So this is the answer for our R or for our modulus. So next, in order to find the theta, we need to sketch for the position of the complex number. Negative 6 minus 4j, whereby negative 6 on the left hand side, negative 4j for the y-axis at the bottom side. So this is our complex number. So now find the theta. Tangent inverse b over a. B is equal to negative 4 divided with negative 6. So by using the calculator, the answer for the theta is 33.69 degree. So the theta that we have here is not the real theta because this one is the reference angle from the x-axis to the complex number. So this is our alpha. Alpha is equal to 33.69 degree. Our real theta is from the positive x-axis until it touch the complex number. So therefore 180 must be plus with our reference angle. So therefore real theta is equal to 180 degree plus 33.69 degree. So your answer will become 213.69 degree. So this is our real theta, which is from the positive x-axis until it touch the complex number. For the next example, example 6, z is equal to 5j. So therefore our modulus R is equal to square root of a square, which is a is equal to 0, 0 square plus b, which is 5 square. So simplify the whole thing, this one will become square root of 25. So square root of 25, this one you can simplify more. This one will become 5. So the modulus or the R is equal to 5. So next, in order to find the value for the theta, we need to sketch, which is sketch for the complex number. We have z equal to 5j. So 5j at the y-axis. So this is our complex number. So real theta move from positive x-axis until the complex number. So that's why our real theta is equal 90 degree. So let's say if you have z equal to negative 5j. So when we plot for the position of the negative 5j, so negative 5j is at the negative y-axis, so negative 5j. So this is our complex number, z equal to negative 5j. So therefore our real theta is from positive x-axis until touch the complex number. So real theta is equal to 270 degree. Another example, if your z is equal to 2. So when you plot the position of z equal to 2, this one is located at the x-axis. So for this one, the real theta is equal to 0 degree and 360 degree. Why 360 degree? Because the real theta is moved from the positive x-axis until it touch the complex number. So that's why theta is equal to 360 degree. So if your z is located on the x-axis, positive x-axis, your real theta will become 0 and 360 degree. So I have discussed with you example 1, example 2, example 4, and example 6. So the rest here, 3 and 5, you can try by your own. And for the example 7 and 8, you can refer to the video. Okay guys, thank you for watching.